So the notes are going to focus on the ALEKS topics that are going to be on the test. So I'm not going to explain all of the ALEKS topics. If you're getting stuck on those homework questions, I can help you. We can get through those. But I want to make sure that our class time is focused on what's going to be on the test. So if we don't talk about something, then maybe that's a good hint that probably won't be on the test. Okay. All right. Okay, so we have these different states of matter. These are some models of states of matter. In the ALEKS homework, on the test, you're going to have to identify different states of matter. So what would this one be?
Solid.
Good. How about this one? Yeah.
Solid.
Almost solid, right? Gas. Okay. So how do you guys distinguish? What are some characteristics that we notice that would distinguish these different states of matter? They're not all going to look like water. They're going to look different. How are we going to tell them apart? Especially if we only have one. Like if we're looking at this one, how do we know that's not a liquid?
It's not like, I guess, jumbled up. It's kind of
Yeah.
together.
Good. So water, liquid is jumbled up. I like that. This one is ordered. Okay, solids are going to be ordered. Liquids are going to be more jumbled. I think gas is the easiest. Gas has a lot of space around whatever we're looking at. Okay. So it sounds like we're pretty familiar with that, but that's something that's going to be really important for in our test. Okay, I think we've got these down. Okay, now let's look at a few things, and we're going to use these examples as we move through. Where did they go? Okay, hold it over here. Oh, yeah, okay. So look at this model. What are we seeing? What's going on? What's up here?
It looks like it's evaporating.
Okay, yeah.
From a liquid to gas.
Good, we've got a liquid. We have a gas. Good. So this is bromine. What kind of atoms do we have here? Are they I guess my question is, do we have all the same atom or do we have different atoms?
All the same.
Yeah, these are all the same atoms. Good. So that's something else you're going to have to distinguish. We'll talk about that in just a minute. Okay. The other, I don't have all of these ready, so we're just going to do a few of them. Here's another thing that's going on. So I have some cereal that's crushed up, and I have a magnet. So see if you can make any observations. Pass that around. So just move the magnet around the side. See what you see. Oh, I got it. Okay, and while you're passing that around, let's look at this one. This is a pretty cool one. Oh, but it's gonna open somewhere else. Oh, and it's not gonna work. There it is. So this person is orange, so we're just gonna kind of fast forward. So, what do we have here?
The dust.
Dust, okay. So I would call that a solid, a powder maybe. We've got two of them. This person is now going to dissolve them in water. And this takes like forever. I don't know, I didn't cut some of this out. So now we have two white solids. Now they're dissolved in water. And then eventually, what's going to happen? So now what do we have? Okay, we've got some kind of mixture. We've got this yellow stuff that's sticking to the side. So it's kind of cloudy. That tells us there's a solid in there. This is called a precipitate. We've got some kind of solid in there now. So we have two white things in there. They were dissolved. Now we got this yellow thing. That's a solid. Okay. All right. So these are going to be kind of reference points for us as we move forward. Okay. So think about physical properties. Which of these would be? So we looked at bromine, we looked at iron in cereal, and then we looked at forming a solid. What one of those, or maybe more, would be a physical property or like a physical change?
Yes, forming a solid.
So we went from a liquid to a solid, so there's a physical change there. Okay, yeah, ice would be, that would be a physical property. Good, solid, liquid, sorry. The color, good, that would be a physical property. Okay, good, so we're pretty familiar with those. Those things about samples that they're just like, that's something we can observe, okay? We can measure them without changing the composition of the material. So we're not changing anything chemically. Okay, so that's the boiling point, the melting point, solubility, color, we talked about color, state of matter. These are all physical properties. Okay, good. And we've talked about this before in science classes, right? You should be pretty familiar with these from like junior high. Okay. All right, so now these are some physical properties that we need to be familiar with. So we've got melting point and boiling point. We're going to define these in our own words. Find my pen. So how would we define the melting point? How would you tell someone what that means? Okay, temperature. Something becomes liquid. Okay, good. Does it matter if it starts as a solid or a gas for this to be true? Right, yep, that temperature is going to stay the same. So the melting point is the same as the freezing point. Okay, those are equivalent. Okay, that temperature is the same. It doesn't matter if you're starting as a solid or a gas. That temperature that it's a liquid, the temperature that it becomes a liquid is its freezing point. Oh, not. I'm thinking the other way. Okay, I'm thinking this way. So we've got I think I just messed up. Okay, we've got solid to go to liquid. There we go. That's what I'm trying to say. Gas is something different. Okay. But if we're going from a solid to a liquid, this temperature is the freezing point. That's also called the melting point. Okay, hopefully that's clarified. What temperature does water melt or freeze? 32 degrees Fahrenheit. And we're going to use Celsius mostly in this class. So what about Celsius?
0.
Yeah, 0 Celsius. Good. So you're going to have to remember that. All right. How about the boiling point? How do we define the boiling point? Okay, when the liquid. So it's a physical change going from liquid to gas. Okay, and just like the melting point, this temperature is the same if we're going from a gas to a liquid or a liquid to gas. We have the same. If we're going this way, it's called a boiling point. What's it called if we're going this way? Going from a gas to a liquid. What's that?
Condensation.
Good.
So smart.
Good. All right. What temperature does water boil or condensate?
80 degrees Celsius.
You're close. It's 100 degrees Celsius. Okay. That's why Celsius is nice. It's we've got 0 and 100. How about Fahrenheit? You guys know Fahrenheit? The boiling point of water when you're boiling on the stove? Yeah, you're really close. 212. Degrees Fahrenheit, good. So again, we're going to focus on Celsius. Okay. All right, but it's kind of fun to know in Fahrenheit too. Questions so far? Okay. All right, so this is a model of a physical change. We have something that's really ordered, a solid. Then it melts. It goes from a solid to this disordered state. And then it goes to a gas, lots of space in between. Okay? You're going to have to pick out which one is a solid, liquid, or gas. Okay. Oh, and we're talking about physical change. So think about some of those examples. Which one of those would be a physical change? We talked, what? Maybe let's go back here. Which one of these examples is a physical change? Okay, ice melting would be a physical change. Bromine going from a liquid to a gas is a physical change. Good. How about this one? If we just could sit here all day and pull out all of this iron in the cereal, is that a physical or a chemical change? That's a physical change, because we're not really changing anything chemically. We're just separating something. That's physical change. All right. Okay, very good. Repeat the next one is, oh, here we go. So this is like an Alex question. So, yes. Yeah, and I'm also recording. Yeah, screen and my voice. Yep. So look at these temperatures. We know that water boils at 100 degrees and it melts at 0 degrees. So for each temperature, tell me if it's a solid, liquid, gas, and maybe if you have a minute, draw a model. What would that look like? Take a minute to do that. 20 more seconds. All right, let's go through these. So at 90 degrees Celsius, what phase will water be? Okay, liquid. Okay, and I would probably draw something like this, where my water is like close together but like disordered. Okay, how about 105? Okay, that's above the boiling point. So what phase is it? Gas. Good. And so I would probably draw a box, and then I have like just a few atoms, or this is my model of water, a few molecules of water floating around. All right, how about this one, negative 14? Good, so it would be a solid. It's below the freezing point. It's going to be a solid. So I would probably draw like an ice cube, and then I'm going to show that all of the molecules in this cube are really ordered, okay, and they're close together. They're closer than the gas. All right, how about 25?
Just liquid.
Good, liquid. Good. Okay, good. So water is pretty straightforward. They're going to give you some that are not just water. So use the same principles that you can do water. Use that on the other problems. Okay, a chemical property is a substance's ability to form new substances. Okay. It's up to you. This one's pretty you because I see some people write. You don't have, these are your notes, up to you.
Alright, it's just.
So a chemical change, what would be a chemical change?
Changing its state of matter.
So that would be like
Oh,
physical
chemical.
property.
Oh,
So chemical change. How is chemical change different? Okay, so you're changing it's so we can tell that a chemical change happened because its physical changes or its physical properties change, right? So like if it changes from colorless to yellow, that's probably going to be a chemical change. Okay, but on our like model scale, what has to happen?
It like alters the molecule structure.
Good. So we start out with something, and we end up with something different. Good. So our bonds are breaking, some bonds are forming. We get something new, a new compound at the end. Okay, good. Let's see. So let's go back to our examples really quick. Oh, I'm going the wrong way. I was like, which of these would be physical or a chemical change? We didn't see this one. Let's see. The magnesium, this was a video of magnesium burning. So that would be, you're gonna do that at least twice in the lab. So yes, that is a chemical change. We're getting something new. Forming a solid is also a chemical change. We're getting a new substance, something new. Our bonds are breaking, our bonds are forming. Okay. I have this chemical sort. So in here there is some different cards with your table. Decide if these things that are happening, is it a physical change, a chemical change, or neither? So watch out, there's one that is neither.
I'm aware. I'm aware of that. I accept it.
I think this is just supposed to breaking it down.
No. I accept the fact that there's just always a higher.
This is chemical.
That's. No. You just like look at it.
I think this one's physical, it's like the little orbs or orbs. You know, I think this one's negative. Well, no, to see like how it goes from like double it's changing like the structure. This one is not. It's this shape. Oh no, because this one's changed colors. Yeah, I know.
Alright, this is going from gas or.
Are you just putting around? Okay,
This is solid.
Yes.
Solid.
I think this could both be.
Is that
One
good?
was also.
This is
I think
solid gas. Solid gas.
You guys have some.
All
You have some.
we have. Six. Liquid, solid liquid.
Okay, no,
It just is though. It just is.
I think that's this one.
This is a chemical.
Yeah.
I'm gonna, I think it's neither. These here don't believe in each other.
Okay, what are you saying?
This one? Is it this one? Which one? We weren't even talking about this one.
So, what are you saying? So explain to me why is that one? Okay, what do you guys think?
Yeah, that's what we were
you guys
thinking.
think. You agree?
Yeah, that's, we said it was solid to liquid.
Okay.
I'm so confused.
Yeah.
Okay.
Each word,
They're
each
at your
word matters.
It's just neither. I think this was solid.
No, it's solid to gas.
Okay,
That is
okay,
gas.
we'll talk about,
This is,
we'll talk about,
I
okay.
can't tell.
so the answer.
I'm gonna have to carry you through this.
Actually,
the go.
However, it's just here.
Oh, I didn't hear
Six cards.
Smart.
All right, let's talk about how we have them categorized. Let me pull up. How do we? Where are we?
Yeah, straight.
Where's my document? There it is. Okay. All right. Let's see if this is upside down in a second. Okay. Let's try this one. What do you guys think?
That's solid to gas.
Okay, so that would be physical. Good. Okay, I agree with that. So physical. How about this one?
Chemical.
Okay, why is this one chemical?
Because it stays a gas.
Green's going to greens.
Okay, yeah, look what's bonded. We got a blue bonded to a green. Now we have blue bonded to blue. So they're switching their bonds. That is chemical. Chemical. Okay, how about this one?
Physical.
Okay, good physical. We could flip it upside down too, right? We could go backwards. Okay, good physical. How about this one? Oh, this
So
looks
it's
like
like chemicals.
good chemical. Why?
Because it's orange and now it's red.
Good, changing their bonding to different things. Good. Okay, how about this one?
Neither. Well, the bonds are breaking.
Okay, bonds are breaking.
Maybe it's so, is it?
So if we start with something bonded to itself, then we have something new. This is gonna have different properties. I would say this one is chemical. That's what I would say. Okay. How about this one?
Physical.
Good, physical. So it's solid. Now they're melted or evaporated. Okay, this last one.
That's.
Is this the neither?
I think it's
What do you think? You think neither?
chemical.
You think chemical?
Yeah.
Well, then which one's
I remember
neither?
there's stuff on the side.
So,
It's gotta
Liz,
be
you think it's neither. Can you explain to me why you think it's neither? Can you defend your answer?
all the other ones were taken.
Okay, all the other ones are taken.
Process of elimination.
Okay. What about this would be neither? That's true. This is neither. So look at what's going on. How many? This is a carbon. This black one is a carbon. How many carbons are there? How many are over here?
One.
1, 2, 3, 4. So we can't start with something and end up with something different. That's not a chemical change. That's like impossible. Okay. I guess that would be like nuclear.
So it's just like Newton's law.
Yeah. The conservation of mass. Whatever we start with, we have to end up with. So Alex will try to trick you like this. So watch out for that. Okay. Okay. That one's neither because we start with 1 carbon, we end up with like 6. Okay, that's not as smart. All right, questions on that? Otherwise, pretty straightforward. Okay, let's close this. Where are we now? Okay. We talked about this. So just look and see a chemical change. It converts one substance into another. We just have to look and see what is bonded together, how many of them. Now, are they bonded to the same thing? Are the right number of atoms? Do we start with the same thing that we end up with? Okay. All right. Let's do another sort. So I'm going to give you these other cards. These are. You have to decide, and this could be, it could go in different categories, right? So we could, if it's a pure substance, it could be an element, or it could be a compound, okay? So if it's a pure substance, it could be a pure substance and an element, or a pure substance and a compound, okay? So it could go into more than one. So I'm going to hand these out. Decide if these are mixtures, compounds, elements, or pure substances. This is just, if that would help. Yeah.
Oh, this is a lot.
This is this is so we have to decide what it is.
Yep. Is it a mixture, a compound, an element, or and the pure substance?
This can be.
I'm trying.
This is only one element. It's not.
Okay, sure.
Wait.
It's like this.
This that's actually a compound.
You're right, it's pure substance.
I think it's a compound.
Okay, so then this.
And you're Trevor? Okay, thanks, Trevor.
Yeah, that's an element.
These?
Okay, these two are.
I think these are pure substances. These two are pure substances. Pure substances. Okay, these two are pure substances.
You know what I'm saying? So I think that these are compound.
Got your picture?
Yeah.
Not sure.
What are we doing?
We're doing a card swap. Oh,
Card sword?
do you want to jump in with Trevor?
Sure. Okay, so what's up?
It fits into the hecky.
So if this here in the left, it's going to say no. So I think these are all just the elements.
So,
I don't think that's right. I think it has to be more. Like this four to mixture.
okay, so this is. Okay, okay, so basically she has to
What?
I don't know.
make it a mixture.
How's it going? Did
Pretty
it?
good.
Here,
All right.
Hey,
all right. I think those would be pure.
So.
Yeah, because they're all like.
So you need that are mixtures. Or
So.
so just keep going through. You got them? Maybe, okay.
so if it's like pushed together, does that mean it's
Unless you don't know what's inside. No, we
What do you
don't
think?
know what's
So you're saying, so which ones would be
I mean, the
compound?
freezer.
It's not compound. So it's compound. Well, like with this being compound.
That is the question.
Actually,
That is the question.
Yeah.
Oh, you like dirty.
All of these are like mixtures.
We need to be Celsius actually.
Can you take one more minute?
Okay.
Decide on your,
Actually, this is a.
Maybe.
your categories.
Watch this. I'm gonna speed run this so quickly. Pure. Pure. Oh, Phil just left
Hey,
us.
Phil.
Yeah.
You wanna help us? We have a few of us gone for pictures, but you can take.
Maybe he's here.
Okay.
here.
He just got back from pictures.
Nice to see you.
Okay.
Yeah,
Okay.
come here.
These are mixtures, which I think.
Yes.
Okay, are you ready? We need a minute. What do you think?
Calm down.
Yeah, if you, so you don't say
I actually.
So we go about three, I'm trying to get three drivers, so we're going 3, 4. We're going
I don't know. Here.
Yeah, no, I'm with that. Yeah, Monday, 3 o'clock, yeah.
I don't know.
Okay. Got it? Yes, I got it. Okay, I'll see you Monday, you're driving, for my driving test. Yeah, got it, okay.
Let's flash you.
All right, let's go back up here. Were there any that you were confused about? Were there any?
Yeah.
Which one?
One of them.
Hold one up and we'll look at it. This one, okay, this one.
Yeah.
What do we think?
That's
Mixtures. I think this is a mixture. We have
I know it.
different,
You just kind of say that.
different things together. This is a mixture, good. Okay, any other ones you're confused about? This is a mixture.
I said it was a compound.
What about this one?
Pure.
Pure.
It's a pure substance, good. Good, what else would this be? Anything else? This is a compound, so this is the question. If it's by itself, is it a compound? We only have one type of atom. Is it a compound or an element? That's our big question.
I think it's elements.
This is an element. There's only one type of atom. So this would be an element. This is also a pure substance because there's only one
Okay.
thing. Okay? One entity, one molecule. Okay. Any other ones you have a question on?
The green and.
Green and purple. Okay, how about this one?
Compound.
This is a compound. Good. What else would this be? We only have one type of molecule here.
So orange, yellow, and blue, pure.
Okay, so this would also be a pure substance. This is a compound. This is also a pure substance. There's only one thing here.
What about this one?
This one.
Mixture.
This one would be a mixture. Yes, there's like a different color of blue. I remember that. Two different atoms. A mixture. So you're saying the one that has orange? That's straight up? You're saying the one that has orange? What?
Yellow and blue.
Orange and blue together? Like this one?
Yeah. Oh. This
No.
one is. Yeah.
This one.
Yeah.
Okay, what do you guys think?
Compound.
I would say we have like, this one would
A
be a
mixture of
compound.
compounds.
Yeah, a mixture of compounds. Yeah, good.
It still works.
Okay, good. Okay, any other ones that you're stuck on or that you want to talk about?
We can't decide.
What about this one?
Compound. That's an element. A pure compound.
Pure element. Pure element. So we only have one atom as an element, and it's only one thing, so that's pure. Okay, good. Okay, how about, let's do one more. Compound.
My life.
This would also be a pure substance.
My life's hard.
Okay, there's only one type of molecule floating around here.
Elements.
Pure. Okay, questions on that? Any others you want to talk about? Okay, that's kind of like an Alex question that's going to be on the test.
Wait, are we taking all our tests on Alex? Like, you do the final?
Yeah.
So Alex is just like doing like the way we used to math.
Do you do tests and stuff in math?
Yeah.
Yeah, with Alex?
And they're all closed now, with the exception of like the front of the note card?
Yeah.
Okay.
Yeah, close out, but you get front of the note card, whatever you want. I don't get to look at your note cards. I just will look and see it's only one side. Okay.
For the first semester I was.
Okay. So let's run through these. I think we have these down, but let's just we have just a few minutes. Okay, a pure substance is only one component. Okay, so it could be a compound, it could be an element. So that's pure, only one component. It cannot be broken down by a physical change. So we can't like sort. So a physical change would be like this one. We are pulling out the iron. That would be a physical change. We can't sort it. I'll come back. We recorded this. Okay, so that's pure substance. Mixture has more than one component. We could sort that. If we could sit and sort the molecules, we could sort that. Or if we had some kind of molecular filter thing. Okay, we are just gonna fly through that. We don't need that. Okay. Let's see. Then let's just look at an element. So nitrogen, if we have nitrogen gas in a tank, that's an element. Even though we have something bonded together, it's only, if we look at this model, there's only one element. So that's elemental. Aluminum foil is another example. There's only one type of atom, so that's elemental. Pure substance, elemental. Okay, and then compound, this is also a pure substance. This is water. All we have is water. That's pure, but it's a compound. Salt is also a pure substance. You can eat it, it's pure, but there's only one compound there. Okay? Yes.
So if there's like one compound and like element that makes it pure.
Yeah, one compound or one element, that would be, both of those would count as a pure substance.
So if you use the water and solids, now
Then-
a mixture.
Yes, yep, that's true.
So it just depends if it's a pure compound or it's just pure.
Good, yep, you got that. Okay, I think that's the end of our slides. Okay, questions on our slides? We just have like 4 minutes left of class. So if you wanna get in Alex and do that tutorial,
Oh, yeah,
or
do we take like the knowledge test too?
yes, you wanna do the knowledge check, don't skip the knowledge check questions. Do as much as you can, because it will put you ahead if you already know stuff. So do your best.
What, we just missed that, and then we have like the tutorial and knowledge now. That we have to do one more.
Yeah.
So the more you know, the less you have to do.
Yes. On the out. We recorded the discussion. I'll post them on the.
I asked you about like this Monday.
Wait,